Hey there, welcome back to another video by Chemical Engineering Life. In this video, we are going to jump on to see how we can build an ideal gas law calculator using Python. So to people who do not know, an ideal gas law is a fundamental equation in chemistry and physics that describes the relationship between pressure, volume, temperature, and moles of a gas. The ideal gas equation itself is PV is equal to nRT. If you're a chemical engineer, I'm pretty certain that you already know what the ideal gas law is and how it's used in different scenarios. So like I said, there are 5 variables that go into the equation. You have pressure, you have volume, you have the number of moles, R, which is a literature value, also known as the ideal gas constant, and you have temperature, which is in kelvins. In many engineering problems, you will have most of the information of the equation, and you will be required to calculate one of the unknown variables. So there are 4 possible scenarios that you find yourselves in. You either have to search for pressure, or for volume, for temperature, or for the moles. So you see on the screen, the ideal gas law equation, that is itself PV is equal to nRT. And if you have to solve for P, for pressure, then the equation changes to P is equal to nRT divided by V. And the same algebraic manipulation is done so depending on what other variable it is that we are searching for. So that's exactly what we're going to implement in Python, that the user would provide the values for the variables that they already know, and they would somehow highlight or tell Python which one of the 4 variables is missing, and Python would then automatically calculate that for the user, giving you the actual value of what that variable should be. So without any further ado, let's get started. So now we are in the Python environment, and now we can finally start writing the code for the ideal gas calculator. We'll start off by writing a comment, which is the Python code for the ideal gas calculator. So just to make it more user friendly, we're going to start by making a heading, which is an ideal gas calculator, and then the 3 equal signs. And then since we need to tell the user that when they need to define the variable which they need to be calculated, they need to write an x for it. So we're going to write x for the variable you wish to calculate. There we go. So now the very first thing we're going to do is creating the input for the variables, because the very first step is that we need to write the code so that the users can give in the value for the 3 variables that we have, and also tell us which variable it is that they're missing. So we obviously have P, V, N, and T, and R, but the R is known to us. So for each variable, we're going to write the input function, and we know that pressure is P, and that is in pressure in pascals. Then we're going to write the exact same thing for the volume. So we know that volume, which is V in cubic meters, N, that is our moles, and that's just basically just N. And we know that T is our temperature, which is capital T in kelvins. So now we have defined the 4 variables, the pressure, volume, moles, and temperature, and we know that the gas constant is basically just joules per moles times Kelvin. And you know what, I'll also write the ideal gas constant. But that is a value that is already known, that is literature value. Anywho, then moving on, now since we have the user, what's going to happen now is that the user is only going to give us the 4 values. So here the user will tell us what the value for P is, what the value for V is, N or T, and then they'll write X for one of them. So what we need to do is we need to convert the above variables to highlight the unknown. And the way we do that is by saying that P, for example, let's say the pressure is equal, if the pressure is the one that we need to calculate, then we're going to write P is equal to none. That none means that the value is nullified if P lower is equal to X. Else we're just going to float the P value. Now this line, what it actually means is that we are saying that if P lower, and the dot lower means that regardless if the user writes a capital X or a small x, it will be converted to a lowercase x. So if, for example, if I'm a user and I make a mistake of writing in a capital X, then Python would automatically convert that input to the lowercase. That's what this dot lower function does. And if you're saying that if the pressure value is equal to x, then p is equal to none. So that means that this variable, this variable p has no value. Otherwise, we're going to float the p value. Otherwise, we're going to be applying the float function. And then we're going to do exactly the same for all the other variables as well. So we have p, v, n, and t. So then I'll write v, n, and t. And then I will do the exact same right here. So p, v, n, and t. And also right in the middle, p, v, n, t. So essentially what we have written now is, just like I said earlier, that each value for each variable will be none if the user has provided a value for that to be x. Otherwise, if the user does not provide the value x, then you will actually end up, we will be applying the float function to that value. Now comes the interesting part. Now we'll be solving for the unknown. And now in that scenario, we're going to use the if function. The if function states that if p is none, then we are going to apply the very first formula, which is just n multiplied by r multiplied by t divided by v. And then we're gonna print out the solution for the user to be able to see. And we're gonna write it up just like this. So you write a backslash, and then we say calculated pressure is equal to, we're gonna write a curly bracket, p semicolon 0 to f in pascals. In this line, what this means is, and when you write the f value, when you write f in the beginning, then you need to define where you want to put the input in, and that is done so right here. And this dot 2f means that we are going to be taking an answer which is in 2 decimal places. If I had written 4, then the output that we would get would be in 4 decimal places. But for pressure, we're going to run with 2. Now, that is only for pressure. Otherwise, what if the volume is none? Then in that scenario, then the volume is calculated by n times r times t divided by p. And then we're going to write exactly the same statement. And we're going to say that the calculated volume is equal to, again, curly bracket, v, the v variable, which is calculated right here. And that is also going to be, in 4 decimal places. That is a meter cubed. And then we're going to say that if n is none, then the number of moles is calculated by the formula p times v divided by the product of r times t. And just like before, we're going to write out a print statement saying that the calculated moles is equal to, again, a curly bracket, n dot 0.2 f, and that's just moles, basically, or mole. There we go. And then the very last one, that is our t. If the t is to be calculated, then t is equal to p times v divided by the product of n and r. And then we're going to write print, and that would be, again, calculated temperature, and that is equal to, again, t 0.4 0.4, and that's because it's 4 decimal places and in kelvins. And likewise here, it's not 0.2, it's actually just 0.2. That means that the output that we're going to get is in 2 decimal places. And for temperature, it is also going to be in 2 decimal places. There we go. And then finally, because when you're writing an if statement, you keep using elif as long as you have the conditions. But if none of these conditions are met, then you write the else function, and then you're going to say print. And then we are just going to say that, all the variables are provided, hence none is to be calculated. So what this if statement is doing right now is that we are saying that if P is none, then please run this calculation, and the answer that we get will be assigned to the variable P, because we already equated that to none. And then in that print statement, we are saying that the Python should then show the solution in this sentence to 2 decimal places to the user. And and we do the exact same condition for the volume, the moles, and the temperature. And if none of these conditions are met, or if none of them are to be calculated, then the Python is going to print out this code or this sentence right here. So now is the moment of truth, and we will go right here and we will run the file. So now we see that it asks us the ideal gas calculator, enter X for the variable you wish to calculate. So let's say we say the pressure is 100 pascals, the volume is 50 cubic meters, and we would like to calculate the number of moles. And you know what? I'm going to go with a lowercase x, and let's say the temperature is 290 kelvins. There we go. And then you'll see that the calculated number of moles is 2.07 mole. Now that I ran the code, I can see that there is a small error. The error being that we have this line showing up with our final calculation. And that is because I forgot to write N there in each one of the lines. What this N does is that it makes a line break. So it's kind of like making a new line right here. Let's try it again. Let's use the exact same values just to see what I have changed. So it's 100, 50, X, and 290. There we go. You see that whenever you write the small n after the backslash, it will bring out a line break between your previous output and the next one. And that's exactly what we wanted. So that's essentially your ideal gas calculator that you can make in Python. And like you saw yourself, very simple. This is like a very basic calculation. And within this one, you can see how you can ask the user to put in the input, and also convert the inputs based on what it is that you're trying to calculate, and then run a bunch of if statements in order for the system to know what exactly it is that is going to calculate. I hope the video was helpful. If you may have any other question, then do reach out to Chemical Engineering Life, and we'll be more than happy to help you in any way we can. Great, thank you, and have a great day.